Hi there. In this video, we'll learn how to graph circles. So in the previous videos, we learned about the standard form of a circle. Question is, if we are given this, how can we convert this one into its graph form? So this will be our problem in this video. But for our strategy, what we do is, given the standard form, we know how to convert this into its center radius form. So if you don't know how to do that, I can link a video somewhere around here discussing how to do this one. And from the center radius form, it's now easy to convert this into its graph form since we are already given of the center. So the center will be this point and the radius. So we can plot it out here. So we have here the center and the radius. So let's try to illustrate how we do this in an actual example, starting with the first example. In here, we are already given the center 1, 2 and the radius 5. So before we start, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So to do this, let's first have this graph out here. And the first thing that we do is we plot the center point. So take note that to do this, since we're given the center, this marks the x part, and this marks the y part. So we know that this one is the x-axis and this one is the y-axis. So we just count depending on this one. So we count once out here, and we count twice on the y. So we have 1 and 2. So the center will be somewhere around here. There. So this is the point 1, 2. And from here, we use the radius to construct the circle. So the technique here is, given the center, we count 5 units upward. So this is 1, 2, 3, 4, 5. Count the same units, which is 5 units to the right. So we have 1, 2, 3, 4, and 5. Downward, 1, 2, 3, 4, and 5. And then we have here 1, 2, 3, 4, and 5. So we count 5 units to up, 5 units to the right, 5 units downward, and 5 units to the left. From here, we can connect this and just make it slightly curved, like that. It's not really the best, but it's something like this. And there is the circle. But if you want it to be accurate, the circle would look something like this. So it's quite similar to what we got a while ago. And so we have completed graphing the circle given the center and the radius. So I hope you got that one correctly. Let's now move on to the... Oops, I forgot that the radius out here is indeed 5. You can measure that. Let's move on to the second example. In here, we're given x squared plus y squared equals 9. Before we start, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So in here, first take note that given this one, we can write this as x minus 0 squared plus y minus 0 squared equals 3 squared. So technically, this is already in its center radius form. Actually, this is like the unit circle, but with radius 3. We just expressed it in this form so that we can easily see the center and the radius. So the center is given by 0, 0, and the radius is given by 3 units. So this is like 3 steps later. 3 steps up, 3 steps down, 3 steps to the left, 3 steps to the right. And 0, 0 out here represents the origin. So using this, let's have this graph. And again, the center is at the origin. So this is the point 0, 0. And in here, again, the next thing to do is count 3 units, since in this case we have the radius to be 3. 3 units up, 3 units to the right, 3 units down, 3 units to the left. So 3 units up, so we'll have 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Then let's try to connect this one and try to make it like a circle. Oops, it's not really, that's not really a good circle representation out here. But if we correct this, it would look something like this. So that is the circle for this example. So yeah, I hope you got this one correctly. And now, take note that if you try to measure one of this radius, like measure this, or whatever, the outcome would indeed be 3 units. You can try that one for your own. And let's now move on to the third example. So we have x plus 2 squared plus y minus 3 squared equals 16. Before we start, again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So in here, take note that this is already in center radius form. But to simplify further, we can do something about this and this one out. So that is, take note that given this, we can express this as x minus negative 2 squared plus y minus 3 squared equals 4 squared. So as you can see, the center out here will be given by the point negative 2 and 3, while the radius is given by 4. So given this, let's try to have this graph and let's try to plot the center. So again, the center is, for the x, it's negative 2 units. So we have 1, 2 out here. And for right, we have 3 units up. So we have 1, 2, and 3. So it's somewhere around here. There. Then given this, we count some units up, right, down, and left, depending on the radius. So since we have 4, we count 4 times up. So we have 1, 2, 3, and 4. To the right, 1, 2, 3, and 4. Downward, 1, 2, 3, and 4. And to the left, 1, 2, 3, and 4. Then let's try to connect this. Left. Oops. This one. This one. This one. This doesn't really look like a circle anymore. But if we do this properly, it will be like this. So apologies for my poor drawing. But yeah. If you try it on your own and it's not perfect, that's fine as long as the idea is there. And you can check here that if we try to check the radius, we'll have 4 out here. So that is the graph for this equation of circle. Let's now move on to the last example. In here, we have x squared plus y squared minus 10x minus 11 equals 0. So we now have a standard form of a circle. Before we start, feel free to pause the video so that you may try this one on your own. Okay, good. So let's give it a shot. So in here, take note that we start by moving negative 11 to the right. Again, our goal here is to convert this standard equation, standard form of a circle, into its center radius form, since upon seeing the center radius form, it's now easier to see the center and the radius, and after that, consequently, we can now easily graph the circle. So we move this first to the right to obtain this. And again, the trick that we do in converting a standard form of a circle to its center radius form is to complete the square. So in this case, what we do is we complete the square for x out here, since y out here is already in the form y minus 0 squared. So we don't really need to do anything about that. So let's move out this to have some space there. And let's complete the square for x. To do that, we focus first on the middle term. So we have 10x. And then we divide this by 2 times the square root of the first term, which is 2x. So divide this and we'll get 5. take the square of this one, and we'll have plus 25. So we have plus 25 out here to complete this square. So we focus this like that. And since we add 25 out here, we also add 25 on the right, since that's how equation works. Apologies for the noise, if you can hear it. Okay, let's continue. Nothing can stop this. Let's go. So we'll have this. So we just simplify the right side of the equation. And then out here, focus on this part out here. Take note that this is a perfect square trinomial. So this factors into x minus 5 squared. So technically, we get the x from the square root of the first term and the 5 from the square root of the last term, which is 25. And we just copy the sign. So that's how it works. Then for y, take note that we can write this as y minus 0 squared, as mentioned earlier, and 36, we can write this as 6 squared. So we'll have this. And now it's easier to check the center and the radius of the circle. So for the center, we have 5, 0, and for the radius, we have 6. So use this to graph the circle. So let's have this graph out here. Let's start by plotting the center. So we have 5 units to the right. So 1, 2, 3, 4, 5. So there. Oops. Apologies if the graph is quite small. Yeah. Then for the y, it's just 0 units, so it's just there. So it will be over here. This is the point 5, 0. There. Then we count 6 units up, right, down, and left. So we have 1, 2, 3, 4, 5, 6 around here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There. Let's try to connect it out here, out here, out here, and out here. My circle is getting terrible. But yeah, if we do this properly, it would look something like this. So it's quite similar to what we had. It's just not perfect. If you check, the radius for this one is 5, or 6 rather. Check the radius from every point. So this is the graph of this example out here. And so that is how we graph circles. So there will be no exercise for this one, since I won't really be able to check if you send your answer, since there's no graph option for the comment section. So yeah, I hope you learned a lot from these examples, and please don't hesitate to comment down below any suggestions and recommendations that you have for this video and the future videos of this channel. So yeah, that's it, and that is all for this video.